All right, so we're going to go through the second quiz here, hopefully helping you make corrections for those of you that need to make them. All right, this first problem here asks us to use Pythagorean theorem to find the third side of the triangle. So in this particular case, we do not know the hypotenuse, which means if we're setting up the Pythagorean theorem, which is a squared plus b squared equals c squared, we know a and we know b, we do not know c. So if we solve this, right, you could use a calculator, but if you weren't, this would be 576. This would be 49 equals c squared. You end up getting 625 equaling c squared. And when you square root both sides, you actually end up getting plus or minus 25. But because, excuse me, not square root 25, plus or minus 25. But because we're talking about a triangle, the positive answer is the one that we're looking for. So c equals 25. Second problem here, find the following trig functions for theta using the triangle below. The key point here is that theta is in this bottom corner, okay, which means that this is the opposite side and this is the adjacent side. So for those of you that missed this, I think that's the part that stumped you. All right, so this is, again, another Pythagorean triple. So we have to use Pythagorean theorem, 13 squared equals 5 squared plus b squared. And when you solve this, you end up finding out that b equals 12. So if we start defining each of our trig ratios, knowing that, all right, we would come up with a fraction for each of them. So we'd end up with sine being 12/13 because 12 is opposite of the angle. That means cosine is 5/13, and that means tangent is 12/5. Once you know those three, obviously you know the reciprocals. This will be 13/12, this will be 13/5, and this will be 5/12. All right, next up here, solve for x, round your answer to nearest tenth. All right, again, we're putting ourselves where the angle is. For those of you that missed this one, for some reason we were using the other angle here. I'm not sure why. Okay, but if we're putting ourselves where the angle is, the x is the opposite side, and we know the hypotenuse, which means we're using sine by definition, which is opposite over hypotenuse. So when I plug everything in, I get sine of 60 equals x over 14. All right, so if I want to solve that, I would multiply both sides by 14. All right, and when I type that into my calculator, all right, I would take the sine of 60 and I'd multiply that by 14, and I end up getting 12.12. All right, now my question does say round to the nearest tenth, so 12.1 would be sufficient. All right, for this next problem here, we're going to type these into the calculator. Calculate each of the following, express your answers, round to the nearest tenth. I think for the people that missed this the most, they forgot that this was in radians, this was degrees, and this was radians. And that was purposeful, okay? So we got to remember to switch our mode. So if the mode of our calculator is in radians, all right, so for this first one here, let's see, let me get the calculator up here. All right. Okay, so for this first one here, we have cosine of 23 pi over 4. So I got to go to mode. I got to change, make sure that I'm in radian mode, which I am here. And I would find the cosine of 23 pi over 4. All right, asking me to round the nearest tenth. So that would give me 0.7. All right, then I got to remember cosecant of 45. So again, I got to go to my mode, switch it back to degree. And if you think Mr. Warner did this on purpose, radian, degree, radian, you are correct. So cosecant is the reciprocal of sine. So remember, this is the same as 1 divided by the sine of 45. All right, not the reciprocal of the angle, the reciprocal of the whole thing. So 1 divided by sine of 45. All right, oh, wait, am I in degrees? Yeah, double check. Good job. Enter 1.4 is my measure there. And then I go tangent of 5 pi over 6. Again, back to radian measures. Okay, so tangent of 5 pi over 6 ends up giving me negative 0.6 if I round that correctly. All right, so I'm done with that for a moment. Okay, unit circle. Draw the reference angle for 120 degrees as it appears in the unit circle. So again, you have the unit circle in your packet. This should be a freebie. Find 120 degrees on there. It's right here. All right, so that would be 120 degrees. I can label that angle. Okay, I can label its reference angle, which would be this one right here. Okay, that's 60. I'd like you to draw the triangle, label all of its parts. So I would drop an altitude here. Okay, some of you labeled the sides as opposites, adjacents, hypotenuse. Okay, I get that, but I'd like to see this as -1/2. This is root 3 over 2. All right, this is 1, and we get all those things because on your unit circle, we define this coordinate as negative 1/2, comma, root 3 over 2. All right, so that would be your expectation there. Find exact values for each of these. Express your answer in simplified radical form. So, again, these are bigger than 2 pi. So we made our own little cheat sheet for that. When the denominator is 4, we're going to subtract 8. Okay, so I'm going to subtract 8 pi over 4 because that's the equivalent of 2 pi. Okay, so when I do that, I end up getting 15 pi over 4. Not enough, though, because that's more than 3 trips around. So I'm going to subtract 8 pi over 4 again. And when I do that, I get 7 pi over 4. This is on the unit circle. So the cosine of 23 pi over 4 is the equivalent to the cosine of 7 pi over 4. So if I locate 7 pi over 4 on my unit circle, I'm looking for the x value there. All right, that, believe it or not, that is a 4th quadrant for those of you that have that memorized. Right there, 7 pi over 4. So the x coordinate here is going to be square root of 2 over 2. So root 2 over 2. That's my best answer. All right, what about cosecant of negative pi over 6? All right, well, negative pi over 6 is not on the unit circle. All right, so if I go negative 1 pi over 6, and I'm going to have to add 12 pi over 6 to it, which is the equivalent of 2 pi, I end up with 11 pi over 6. Okay, so that means cosecant of negative pi over 6 is equivalent to cosecant of 11 pi over 6. It means the same thing as negative pi over 6. Okay, but we can't find the cosecant because it's not listed on a triangle, so we're going to look for the sine of 11 pi over 6, and you're going to find out that that is negative 1/2. And then obviously to get this answer, I'm finding the reciprocal there, so negative 2 is my best answer. All right, on the tangent of 5 pi over 6, so I'm going to locate that on the unit circle. I'm going to need the y and the x value, okay, from that coordinate. So the y value here is 1/2, and the x value is negative root 3 over 2. It's a second quadrant angle measure right here. Okay, so x is negative, y is positive. This answer here isn't the best answer, so I'm going to instead take 1/2 and multiply it by the reciprocal, which is 2 over negative root 3. In doing so, I sort of create another problem. All right, my 2's cancel. I'm left with 1 over negative root 3. Again, I told you I'm not grading this too hard, okay? But if I rationalize this for the best answer, I would get negative root 3 over 3. All right, so given the tangent of theta is negative 5/12, and that theta is in, this is quadrant 2, okay? So I'm first going to draw my triangle in quadrant 2. The triangle itself is arbitrary, so it doesn't really matter how you draw it. Okay, I'm going to label the sides I know. Remember, I'm talking tangent here, so that means this is y and this is x. Okay, so when I come over here and label my triangle, my y value was 5, my x value is negative 12. Okay. I'm going to go ahead and use the Pythagorean theorem to find the third side, which is 13, and then I'm going to go about defining each of my trig values, assuming theta is right here. Theta is always the inside angle, okay, which touches the origin for this. Some of you were labeling theta as a different angle there. So when I do this, sine is going to be opposite 5 over hypotenuse 13, cosine adjacent negative 12 over 13, and tangent opposite 5 over adjacent negative 12. I do the reciprocal of each of those, all right, for my reciprocal, okay, and then I end up with those ratios. Some of you forgot the negatives for the 12, forgetting that you're in the second quadrant. Last, a radio transmission tower is 200 feet tall. All right, so the tower itself is 200 feet tall. Okay, there's a guy wire that's attached 14 feet from the top. That's the trick part of this question. All right, and that guy wire attaches to the ground. All right, down here's the ground, and it makes an angle of 23 degrees with the ground. How long does the wire have to be? So many of us that got this incorrect used the 200, okay, as the height of that triangle, when in reality, that wire was attached 14 feet below the top of the tower, which means we would rather use 186 feet, okay? And that would be the opposite side, and this would be the hypotenuse, which tells us we're using sine of 23 equals opposite 186 over hypotenuse x. Some of you had those flip-flopped and have it set up correctly. Here's a scenario where cross-multiplying helps, so I'm going to go x times the sine of 23 equals 186. I'm going to divide by the sine of 23 from both sides. And that will be how I find my answer. So x is going to equal 186 divided by the sine of 23. All right, so 186 divided by, better check my mode because I was in radians last time. Good thing I did. Sine of 23. So it gives me 476 feet for the length of the wire that it would take to do the job. All right, so there's your 8 questions for your quiz. Not a bad idea to watch this. Maybe watch it again. Go back and redo the problems you missed and get ready for your tests.